Hello everybody and welcome to episode 7 of this series where I teach you how to build a redstone computer. Last time in the 6th episode I taught you how to build the ALU, the unit that does the arithmetic and logic, all the adding, the subtraction, just all the different calculations. But today we need to store those bits, so we'll be taking a look at the registers. This entire blue thing are the registers. So like I said, the registers are for storing bits. But you might ask, isn't RAM for storing bits or a hard drive? Well, yes, but the difference is, for example, RAM, that's outside of the motherboard in a real computer. Registers are inside the motherboard. There are a lot less of them, but for units like the ALU, it's a lot quicker to access it. And most of the time they have a ladder assigned to them, so register A, register B, register C, register D. I usually don't do that though. I just refer to them as register 1, 2, 3, and 4. This computer in particular has 4 addresses, which can each store up to 4 bits. Now you might ask, what is a address? To explain it, I'll sketch a little situation. Imagine, you just calculated a number in the ALU and you send it through the bus. And you store it inside the registers, inside one of the registers. Now if you need that number later, you will have to know where you stored it. So each register gets assigned a number or binary code. So when you need a particular number, you just look at the binary code of where you stored it, you put it in the address lines, and you will get the output from those registers. So that's an address. An address is just one particular place. So this is address 00, 01, 10, 11. Again, I use those store modules like I taught you in episode 4, I think. I use them a lot. Again, over there, but for a different purpose. They are stacked next to one another with one space in between, and a little bit of space on top of each other. This is one address, so don't look vertically, look horizontally. You can get a little less space, I think, with vertical, but I didn't really look at it. Now, how to build the registers. First, let's look at the different input lines. You have your normal 4 input lines from the bus, your data lines, and you also have 4 output lines if you want to get information from the registers. Aside from that, you have the 2 address lines to determine which module of register you want to use. And then you have a write and a read line. If I refer to write, I mean storing a set of bits onto the registers. If I mean read, I mean looking at those bits and getting them into the bus. That doesn't mean they have to be gone. They just stay there, but you set them also on the bus. So those are the different inputs. How does it work? The input lines, quite simple. You just run them through all of the different inputs. So just run them, no security, that's for later. Just run them right into it. I use sticky pistons and slimes and redstone blocks to elevate and descend the different signals. So here I use them again. Next, the 2 address lines, the read and write line. The other 4 lines are a little bit more complicated, but it's doable. Why? Well, you only want to read and write line to activate on one certain module, not all of them, because if you do that on all of them, for example, if you load here 0001 and you activate the write on all of them, they will also 0001. And that's probably only want to store it to 1 bit, so you can overwrite things you have already stored. And for the reading, it's even more problematic because all of them will just overwrite. If they're all the same, it's not a problem, but they will just overwrite and your data is gone. How do you solve this problem? Well, we take the 2 address lines, these are the 2 address lines, and we run them through this thing, the decoder. And what this does, for example, here it has 0, 0. This line, so it breaks them up into 4 separate lines that can either be on or off, of course. And this line is, for example, the 0 line. This is for if it's 0, 1. This one is for 0, 1, 0, and this is 1, 1. So we take the register lines and we run it through this. Now this is quite a smart system, I would say. What this does, it will if this line, for example, is on, here there's a repeater, and it will power this line. I'll disconnect everything for a moment. Wait, this is a problem. Oh, I did it wrong. Anyway, it doesn't matter. So, and I'll shut that off. And I'll shut this off, and I'll take a lever so I can illustrate it there. Here and here. For why this was on is I'll explain in a minute, but it's because we first need to invert it before the system starts and then later invert it again. So what is this? If it's just zero, if it's just zero, like if this goes on, I'm sorry, if this goes on, then this goes 0. So if the right line is on, this goes to 0, and that means the system needs to activate. But what it will do is it will power all the lines that aren't supposed to be powered. Now how? In this case, for example, it's 0, 0. But I'll make that. For in this example, this line is on, and with this repeater, it goes to the next one, but it also powers this line beneath it. Why? Because this bit needs to be a 0 for this line to activate. So then we invert it again, and why it doesn't work now is because this line is in, then it will work. So then we invert it again and it goes off. But for the next one, I'll make it also. So which did I? Okay, I did. For this one, it also powers it because this also needs to be a 0. But for the next one, here you have a redstone torch. So the redstone torch goes off, not powering this line. And also, this line needs to be off for this particular line to activate. So we use a repeater, and because this line stays off, this line won't go on. This is just an AND gate actually. And then, I mean an OR gate, and then we invert it, and it goes on. Again, this time I use honey for some reason, I generally don't know why, to elevate the different possibilities, the different signals. How do I usually build these? Well, I make the 4 lines, For black I use 0, for 1 I use white, so I lay it out 0 0 0 1 1 0 1 1. Then I replace I place the resting torches aside the white concrete and repeaters in front of the black concrete, and then we need to invert it and invert it again. So that's how you select the different lines for the different modules, so you can only select one module. It works exactly the same with the read, just the different line for read, so you don't use the write line, you use the read line, and the signals go to here. So how does this work? Here, this line always reads the output from what this has stored. So we need to make a system that it doesn't always get transferred through. How do we do that? Well, the same way actually. Like I said, you just use this. So this is the same way. And then, but instead of this, of going up, I mean, it does go up, but instead of going into here, I mean, it goes all the way to the end. I'll explain it here. So when this line goes on, it will power these sticky pistons, extending this block, which makes the signal pass. That's it, pretty easy. Now there's one thing, and it's really weird. I won't show it because it will completely mess up my computer again. But I had to manually move these repeater because sometimes the pistons don't extend, and maybe if I move this repeater maybe back, there's a good chance one of the pistons won't work. I don't know why. I think it's a bug. Maybe it's fixed now in this version, but I won't try it. Just be aware. And I could not find any reasons for that to happen. Next we have the same circuit we used in the ALU, so if you want to know how that works, I won't explain it again because it's pretty insignificant, just a security circuit. And then again, we have the same thing like in the ALU, where you can control when the signal needs to be transferred to the bus, so you can write it to the bus, and if you want to replace it with and it stays there, although even if this line changes, and if you want to replace it with another number, you can, or with these sticky pistons and redstone blocks, you can set it to 0. So that's pretty much it. Let's do a quick recap. So in this register can store up to 16 bits, 4 bits for addresses. An address is just one module to know where you store your bits. Your input lines just go right into all the different modules. The security system happens over here, where you can select the different modules with the different address lines. So you invert it over here, you power it when it doesn't need to be powered actually, and you invert it again. And then this goes to all the right lines, then this goes back all down. Then you have another such a system with read lines, and you have these sticky pistons to only let the signal go through if you select that different module, that particular module to read. And then, oh yeah, I explained it not entirely accurate. The read line actually doesn't go to here. It always reads an address onto these lines. It's just here that the read line actually comes in. So when you activate read, it just activates this line and it will write that to the bus. So then it's that system that I just explained, and you can set it to 0. Those are the registers. your module to store your different bits. Thank you all guys so much for watching. If you have any questions, leave them down in the comments below. If you enjoyed it or learned something from it, please consider subscribing and liking. It would really make my day. Oh, that was... Oh, damn. Doesn't matter. Have a good day and bye.